Welcome back, everyone. For our next presentation, we have Maciej giving a presentation on composable interoperability built with Substrate. Maciej?
Good evening from Berlin. Yes, thank you for having me here. Indeed, today's talk is all about composable interoperability built with Substrate. And it's also my attempt to give a technical overview into a system we create to facilitate building and executing smart contracts into multiple chains, therefore interoperable. There will be a couple of examples of interoperable smart contracts moving further. But before we dive into this, I would like to paint a picture of where smart contracts stand now when it comes to composing execution cross-chain. And also, hopefully it allows us to understand a bit more, a couple of architectural decisions we made creating the system. Any product really that does execution around smart contract is expected to come with two properties, being fail-safe and composable. Composability gives us this nice effect where we can cascade the solutions based on the blocks we already have. And fail-safe, meaning we are, even if execution is broken in between multiple steps, there will be no side effects in the form of some unfinished transfers on the chains that we create. On top of that, there is additional twist that we are building into t3rn, which is on-chain rewards. And this comes from two origins. The first origin being we would like to be involved in adding additional push to open source developers, giving developers chance to be remunerated for the work they are doing. And also, it also comes from the fact that building a new solution in Substrate really gives us an opportunity to design the economy of a system from ground up, meaning that we don't really inherit any economical boundaries that are happening, let's say, in the other platforms where all of the fees would, in most of the cases, go either to miners when it comes to proof of work services or validators for proof of stake consensus systems. Here in this case, we would like to create a system which gives developer to really build out a new underlying economy of their own smart contracts and decide what would fit best into their specific solution. The smart contracts all will be hosted in an architecture thing, which we call on-chain contracts repository. And physically, it's nothing else but a palette built out with Substrate that is storing the, for now, WASM binaries of the contracts that come to us, and at the same time is able to track and pay-per-use for all of the executions. We do believe it's important for us not to give too much of requirements for developers and leave them a freedom of how they like to create their own smart contracts. Therefore, anything really that compiles to WASM is fine with us. Developers could still write their contract in Rust using Ink, the smart contract languages for Polkadot ecosystem, or stick with Solidity or assembly script. To illustrate really the use cases that has been proven very powerful of smart contracts and its composability, it's worth to consider the DeFi Blocks composability. On the example here, we see a custom trading logic, which is connecting together three consecutive calls. First of all, it swaps one pair, then it feeds it to a liquidity pool. Then, given the LP tokens, it feeds the LP tokens to another smart contract that would generate APY. In some sense, when it's happening, all of Ethereum creating smart contracts with Solidity really comes by default with this very functional feature, meaning, let's say, in case there is an error in the second step out of 3, in case we run out of gas, let's say, while adding liquidity to the pool, there will be no side effects in the sense that the swap will also be rolled back. So in turn, we attempt to really make this very specific case of DeFi blocks at the same time more generic and at the same time elevated to a multi-chain layer. And when we think of some additional use cases that can be composed of one another, it's easy to see that the examples that we'll be showing in the later parts of these presentations, it's relatively easy to compose together not only DeFi blocks, but executions in general, compose the modules from decentralized governance with decentralized data or autonomous organizations. So if we would like to simply elevate the smart contracts to a cross-chain level, we would simply realize that it's becoming more difficult because we need to abandon sort of the synchronous way of developing a smart contract if you would have done it, let's say, in Solidity and Ethereum, where we can simply rely on the values that we calculated a bit before in the smart contract execution. And we are relying on the fact that physically all of the data that is necessary to calculate the smart contract, both the smart contract code and underlying state, sits on the same machine. In the example here, we would elevate the computation of a single value to the cross-chain case. And now we need to start dealing with the fact that at the same time, we would like to update a value that resides on another chain. There could be another actors involved in updating the same smart contract in a similar time, and we really have no control over the order of how would those informations be saved on a foreign consensus system. So state reads are becoming asynchronous. At the same time, handling errors becomes also quite problematic when we are dealing with the fact that smart contracts execution is now composed out of blockchains, which are in its nature immutable. So keeping the previous points in mind, in turn, we really like to think of our smart contract to be closer to a state machine which has an input. The results would depend on the input and also on the local execution state that would be present throughout the whole execution of interoperable transaction. We abandon the instantiating step that is present in most of the smart contract systems. And instead, we would now carry on with passing the state throughout the next steps, with at the same time coming with the whole blockchain setup that would give in an open way sort of an insurance over execution, where all of the parties would be able to participate in the execution and acting accordingly to the protocol, pass the messages between different chains. The messages that will be passed between different chains from now on are we calling side effects, and those are really the commands, the operations that needs to be now delivered into different chains, and also based on how developers wrote the smart contracts, there can be some dependencies into order in which side effects will be passed on and proofs relied back to the circuit. So this is pretty much where we arrived at now. We have a circuit, which is a blockchain that is able to both store a couple of composable contracts and is able to trigger the execution of those, at the same time producing side effects that in the later parts would be delivered into foreign consensus systems. It's important to notice perhaps that trigger in our design is something pretty generic, meaning that it could either be a call, a simple RPC call, but not necessarily. It could be a change on a different account, or a message passed from XCM when it comes to integrating with Polkadot ecosystems. So the first example showcases how we could freely move within a smart contract and pass the execution over Polkadot and Kusama Parachains. In this example, we would see that after receiving an XCM message trigger, the execution of a custom trading logic will fire and would also receive some additional data from Ethereum, use those data to calculate the exact values that then will have to be swapped using a Karura, and then with those two additional transfers, we would also perform them in a native way to both Karura and Kusama. So we arrive with a system that is able to pass the messages and at the same time gives a fail-safe guarantee that all of the steps that we wrote within a smart contract will come as an atomic operation. The next example demonstrates the use of another trigger, another than XCM, where it's possible to register an observer that would observe a particular account on a foreign consensus system. Here in this example, it's a blockchain. And the example really is meant to showcase that the system we create is meant to be adaptable and work alongside with many consensus systems, and therefore we believe useful. The smart contract logic we see on the slide is doing pretty much something similar to what we saw on the previous example. Also some custom trading logic, receiving amount of value in Bitcoins, utilizing the price that would be proved to be already valid from Ethereum, utilizing this price to calculate several swaps and transfers to Alkaline Ethereum. So the previous two examples, they were relying on the assumption that we would really like to treat the execution as an atomic transaction and make sure that all of the steps would go within the transaction, or none at all, and the side effects would be cleaned up throughout the different chains. In this example, we see that we also could rely on the state to split the execution between two consecutive, from the perspective of a blockchain time. So the execution here would be able to pass on the results into a state and rely on the next state updates to have some additional conditional code branches that would either be active based on the calculated results and execute or not. Alongside of the code changes that we create and the system that we create as part of the MVP, we also focus on delivering the first attempt to present a user interface for composable execution. We see that the usability aspect is sometimes overlooked, and we would really like to provide a good way and a good insight to what's actually happening behind the scenes after we submit the smart contracts for execution, and also at the same time give nice tools for initial developers creating smart contracts with our systems to get their head around and really make the first nice attempts to creating the backbones of future composable smart contracts. So the first slide demonstrates how we could compose on one another, following operations that would happen into different consensus systems, into different chains. If you are wondering how does it happen that those operations are available to choose, the next slide should provide better insights into it. So this view demonstrates hypothetical projects that could be integrated with t3rn. And on the horizontal line, we see the next platforms that offer series of operations that are available to be selected from. So at the same time, new projects integrate with t3rn. Developers would give, while creating the smart contracts, developer would get the additional extra features to build the smart contracts out of. So far we learned a couple of things about the smart contracts with t3rn. Now, in the last part of this presentation, I would like to overview quickly how does it happen that we can rely on the smart contracts being executed in a trustless way, following the t3rn protocol. So the main architectural piece of the whole project we call Circuit. Circuit is nothing else but blockchain created with Substrate that is facilitating the fail-safe execution and becomes this dictator of execution protocol between all of the connected members of the circuit. It stores all of the smart contracts being able to be reused and executed. And at the same time, it acts like a judge for all of the proofs of side effects that will be transmitted into foreign consensus systems, and allows the whole validation logic to work in an open and trustless way, allows validators to join the system securely and also be the facilitators of the smart contracts execution. Oh, sorry. Everything that is coming out of the gateway, which is the receiving end, which we call gateway. So gateway is for all of the systems that are willing to join t3rn. It acts like a plugin for interoperability. So the system that is willing to install a gateway in some form automatically opens up to the wider blockchain traffic that comes from the cross-chain execution. And at the same time, being installed within the t3rn ecosystem, developers could now select the features operating on this particular chain in their own smart contract. So it's sort of a win-win situation there. It's what physically the gateway could be. It really depends on the features of a consensus system it integrates. So for Ethereum, it could be external gateway being a form of a smart contract. For Substrate-based projects, we also come with a palette that is able to receive the messages in a most trustless way. And at the same time, if the target chain doesn't present the chance for us to install anything there, we also can fall back to the simplest gateway that is relying on multi-signatures by our escrow accounts plugged into and being active in the t3rn blockchain, and the security falls back into trust on the t3rn ecosystem. The slides and the examples that you saw on the previous slides, they are all part of MVP alongside with the front end. So as part of the MVP that should be ready by the end of this year, we want to release the circuit, give opportunity for developers to start experimenting and building out the first use cases of smart contracts. At the same time, we would like to introduce other projects and help build out the first integrations into t3rn. What comes later is a focus on adding the more security, opening up the whole system to the escrow accounts that would then be able to bond their stake and take an active part in the smart contracts execution, with our overarching goal to become a Parachain slot. As a closing thought of my today's talk, I would like to display our mission. We believe in the trust-free collaboration, and therefore we create a system that allows developers to freely build and create the smart contracts in the way that is able to remunerate them for the original work. As a thank you note, I would like to invite you to join our community. As of yesterday, I believe we also opened up a Discord channel. About this, you can learn on our Telegram official site. And we also would love to welcome you into our development team, at the same time as welcome you into our first developer community building out smart contracts with t3rn. Thank you so much.
Okay, thank you very much, Maciej. That was a really, really cool talk. I loved the level of abstraction you had in that in the code examples you gave. Just one question, and then we'll end. Is now ready to use? Like I know you said that the MVP would be out, but are there current versions that people can play with now, or is it not quite ready for them to use?
The short answer would be we would like to prepare all of the onboarding and documentation for the MVP to be ready, as mentioned, end of the year. Technically, it could be ready to start experimenting and building out these smart contracts, since all of the architecture and palette pieces are there. But we are simply now in the process of verifying everything, covering up the missing links and pieces. So yeah, it probably could be a pretty bumpy road for developers to start doing early experiments now. But we definitely are mindful of the fact that we would love to welcome developers and have it sort of like prepare the safe landing for them. So we have already started working on good documentation and the good onboarding portal for developers.
Okay, great. Well, thank you very much. That was a very interesting presentation. And I'll ask everyone to just hold on for a few moments while we prepare for the next speaker.